Assalamualaikum and good afternoon. So can you hear my voice clearly?
Salam, and yes,
Okay, thank you. Alright, so today what we're going to do is we're going to discuss the last topic for this course, so which is going to be chapter 6. So chapter 6 actually, if I were to compare with all the chapters that we have discussed, I think that chapter 6 is going to be the easiest. So that is why whenever student, couldn't do the calculation for chapter 6, I think it's such a waste because so the calculation is going to be pretty easy and it's going to give you a lot of marks. For example, one question could give you along like at least 9, 10, 11 marks. Okay, so and there's going to be definitely going to be two questions on chapter 6, so that is going to be about a minimum of 20 marks from chapter 6. Okay, so that is a lot, 20 out of 100, so that is a lot of marks. So that's 1/5 of the whole mark. So therefore, so today we're going to sort of like, I'm going to give you an overview, a summary of what is being discussed in chapter 6. Okay, first of all, in chapter 6, there are two topics. One is known as the goodness of fit test. So the other one is known as the contingency table. So in goodness of fit test, as what we have over here, so this is goodness of it. There are going to be two subtopic under goodness of fit. So which one is called as the goodness of fit for categorical data. So you're going to be given a categorical data. If you remember, categorical data is a qualitative variable, so it has categories. So that is called as categorical data. And then we are going to subtopic number 2. So it's going to be on goodness of fit, but we are going to test for distribution. So those are going to be two topics. But the good news is that, so the idea for both of them is going to be exactly the same. So what happens is that whether it's going to be goodness of fit for categorical data or whether it's going to be goodness of fit for distribution. So in terms of the calculation, so in terms of how it is being handled, it is going to be exactly the same. So the only difference will lie only on the, on the hypothesis. Other than that, exactly the same. Okay, so what happened for goodness of fit of categorical data is that, so it tests whether the frequency follows certain probability ratios or percentage. So you're going to be given a probability or ratio or percentage, and you're going to test so whether or not the data that you have actually follow this particular probability ratio or percentage. So there are two terms over here, so which is observed frequency and also expected frequency. So observed frequency is whatever that is given in the question. So then the figure frequency given in the question, so that will be called as being the observed frequency. So expected frequency is what we calculated by using the probability ratio or the percentage given in the question. So we're going to call that as being our expected frequency. So the data, we're going to call that as being a good fit. So meaning that, so the data is going to satisfy. So this sort of like a condition, the claim that we have is the difference between both of these value are small. So if our observed value is pretty much similar to our expected value, so that means that whatever ratio that is given, whatever percentage that is given, so it's actually true. So that is going to be the case that it is called as being a good fit. So we're going to test so whether or not the observed and expected is a good fit. So that is why it is known as goodness of fit test. So this will be the hypothesis, and this will be for the first one, goodness of fit for categorical data. Okay, for the case of categorical data, so this will be the hypothesis. So we're going to say that there is no difference. So there is no change, there is no preference. So when you come across something that looks like this, the keyword is no difference, no change, or no preference. So it should be on the null hypothesis. And when you come across something that calls for a difference, a change, or preference, meaning that the difference, change, or preference actually exists, so you are going to put that on the alternative hypothesis. So this comes from experience. So if you do a lot of exercise, you have seen the example in the book, so you will be able to grab the concept. Where are you going to use this? Or instead of like, if you don't have this as the keyword in the question, so it could also be something like this for goodness of fit test. So we're going to state the claim of the categorical distribution, for which what happened is that, so we're going to say that so our our data actually follows whatever probability, percentage, or the ratio given. So that is going to be rational. So we're going to agree So with whatever that has been given in the question. And the alternative is going to be the opposite, so which we're going to say, so it is not the same as being stated in the question. So agree with, let me put over here, statement in the question. Okay, and for the alternative hypothesis, you're going to disagree with that. You're going to say that it is not true. So that is going to be always the case for our goodness of fit test. Okay, the procedure, so how do we do goodness of fit test is going to be the same procedure as what we have done for our hypothesis testing. So step number one is going to be to state your hypothesis, rational and alternative. Step number two is you're going to compute the test statistic. So O over here stands for the observed frequency. E over here stands for the expected frequency. So you're going to, for each of the category, for example, if you have a K in the qualitative variable, we have 4 categories. You're going to do for all K. So the fact that you're going to find what is going to be the observed minus expected square. So divide by the expected value. And then you're going to sum up all the values for each of the category. So that will be step number 2. And that is going to give you the value of the test statistic. So step number 3 is you're going to find the critical value. So the critical value is given by the chi-square distribution. So it's going to be chi-square alpha k minus 1. So as I mentioned just now, so k stands for the category. How many categories are there in your variable? Okay, so the goodness of fit test is always going to be a right tail test. In fact, all the tests that we are going to see in this chapter, they are all right tail tests. So you don't have to worry whether it's going to be right tail, left tail, or two tail. It is always going to be right tail. All hypothesis testing in this particular chapter. So after we have decided whether we're going to reject or do not reject, and of course the last step is going to draw a conclusion. Okay, so this is going to be for the other one. So goodness of fit for distribution. Okay, for distribution, what happens is that you're going to test whether or not, so this particular data follows a Poisson, binomial, or a normal distribution. But you don't have to worry about this, what I call that distribution. You don't really have to know about them. You just have to know how to calculate, so whether or not, so it follows this particular distribution over here. But you don't have to have the knowledge about Poisson, binomial, and normal. So what is going to be the hypothesis? So the hypothesis is that we're going to say that the population of a set of observed data comes from this specific distribution. So the highlight is that it follows the distribution that is given. The alternative hypothesis, we're going to say that it does not come from the particular distribution. So we're going to agree with the distribution in null. We're going to disagree with the distribution in alternative. In terms of procedure, it's going to be exactly the same as what we have seen before. You state the hypothesis. This is going to be your chi-square. And if you notice, even the formula is exactly the same. However, the critical value will be slightly different because previously, for goodness of fit for categorical, we have a chi-square alpha k minus 1, but now this is going to be k minus m minus 1. But you don't have to worry because we have actually revised our syllabus starting from last semester. So what happened is that previously when we have this kind of question, probability is not given, meaning that you have to calculate the probability. So what is going to be the value of your m? So it's going to depend on how you calculate your probability. But as we revised the syllabus last semester, what happened is that the probability is given. So therefore, for your case, m is always going to equal 0 because you are not going to calculate the probability. It's already given. So therefore, n is going to equal 0. So if we were to change m equals 0 automatically, so this is going to be the same as the previous hypothesis testing. And of course, the rest of this procedure is going to be the same as well. So this is also going to be always a right tail test. You're going to decide whether to reject or not reject, and then you're going to draw a conclusion. Okay, and for the case of the expected value, so how do we calculate the expected value for the goodness of it? So the rule is that expected value is equal n. N is going to be our number of sample. So multiplied by the probability. As I mentioned, for goodness of it for distribution, so the probability is already given in the question. But for the case of categorical data, so it will be given in terms of either you have to find the probability in the question itself, or it's going to be given in terms of percentage or in terms of a ratio. So we will have a look at this together later in terms of the example of how is it given in terms of percentage and also ratio. Okay, so what happened is that, as I mentioned just now, so what we did is we compare between the observed minus the expected value. If the difference between the value of both of this is small, so observed value is very similar to the value of the expected, we are going to say that our function is a good fit. So good fit meaning that, so observed and expected is actually pretty much similar. So meaning that whatever that we claim in the question is actually true. So if we claim it comes from normal, yes, it is normal. If we claim that it is given by that ratio, then yes, it actually been given by that ratio. So meaning that our sample totally agree with the claim. However, I want you to be careful when you find the value of the expected frequency. So that is going to be one important condition that you have to check every single time. So the fact that the expected frequency for each category, meaning that for each of the category, you have to check that the expected frequency must be at least a value of 5. So what happens is that if the expected frequency is less than 5, you have to combine the frequency with the adjacent category. So you have to combine it with the next category and put them together. Okay, for example, so let's say I'm going to call this as category 1, category 2, 3, 4, 5, 6, and 7. So I have so many of them. Okay, so these are going to be my category, and this is going to be the expected value from my calculation, for example. So now I'm going to check for each of the category. I have to make sure that they must be at least 5. So if it is lower than 5, so I have to combine with the adjacent category. Adjacent means right next to it. Okay, so what happened is that here, the problematic category will be category number 1, so category number 4, and also category number 7, because all of them have value that is less than 5. So what would you do if you come across a frequency that is less than 5? You are going to combine. So what happens is that for this case, because this is the first data, I have no other choice. I have to combine it with the second data right next to it. So therefore, I'm going to put them together. So now they are going to be in the same category. So 2 plus 5, this is going to be our new category, which is going to be 7. So this one, we just retain as it is because there is no problem. But then again, for the fourth category, so this is the value of 2, so it is lower than 5. When your category is in the middle, right, for this one, we have no choice. When we set a value right next to it, because it's the first data, right next to it will be data number 2, the second category. But for the case of number 4, so we have a choice. So we can either combine it with category number 3, or we can also combine that with category number 4. However, in real data calculation, so most of the time we are going to combine that with the category right next to it. So it doesn't matter if you want to combine with 7, so that should also be fine. Okay, however, so the most common is combining the frequency with the category which is right next to it. For this case, I combine the 2 and the 8. So therefore, my new category will be a combination of them and have a frequency of 10. And the same goes for the similar idea will be applied for category number 7 as well. So I have a frequency of 3 less than 5. So I have no other choice because it's the last category. So I'm going to combine with the category that comes before that. So 3 plus 8, so that is going to 3 plus 5, that is going to equal 8. So what happened is that I started with 7 category, but because of the condition, so now I end up with 4 categories. So 1, 2, 3, and 4 in your calculation. So previously we have k equals 7, but after we check for the condition, so now we only have k equal 4. So that is what you're going to do every single time after you have calculated the expected value. So you have to check for the condition. So if it's not satisfied, you have to combine. Okay, and then this is going to be subtopic number 2. So previously we talked about goodness of fit, and now it's going to be contingency table. So contingency table can be used for two situations. First, it can be used to conduct the independence test. So you have 2 variables. So you want to check, it's going to be categorical variable. So you wanted to check whether these 2 categorical variables, are they related or not related to each other. So do not get confused this with regression. So remember, regression, they are for quantitative variable. They are in terms of numbers. But this is for qualitative variable. So for qualitative variable, so if you want to test the relationship between both of the variable, so you're going to do the independence test using the contingency table. And then you also can have the homogeneity test. So homogeneity test, so we test for proportion. So let's say if I have three category, so I wanted to see if the proportion in each category is going to be the same or not. So that is going to be called as being the homogeneity test. Okay, so the name is different. One is called as independent test, one is called as homogeneity test. But the thing is that only the hypothesis will be different. It will be the same as the goodness of it. However, so what do you call that? In terms of the calculation, so it is going to be exactly the same. So even if you're not sure whether this is independent test of homogeneity, so your calculation is still going to be the same. But you might get it wrong only for the hypothesis. Okay, this is going to be the hypothesis for both of them. For independence test, so the H null will be, so we are going to say that both of the variable is independent or not related to each other. So that is always going to be our null hypothesis. The alternative would have been that the two variables are dependent or related to each other. So now x has no relationship with y, alternative x has relationship with y. So that will be our hypothesis for independence test. And then for homogeneity test, we're going to say that all proportions are the same. If you notice, this is pretty much similar to ANOVA. The only difference is that ANOVA we test for mean, but this one we test for proportion. Even in terms of the, what do you call it, how you written the hypothesis is also exactly the same. The only difference is that instead of using mu, so you're using pi, which represent the proportion. And the alternative will have been at least one proportion is different from the other. So you have a choice. So whether you're going to write it in terms of a symbol like this, or you want to write it in terms of words. So either way, so both of them are going to be correct. But if you want to write it in terms of symbol, you have to be very, very careful. So remember, you have to be very careful on how many proportions are there in the question. So safest way would have been writing it in terms of words. You can put all proportions are the same, and alternative, at least one of the proportion is different. Okay, so this is going to be the procedure for contingency table. First, you state the hypothesis. Second, you compute the test statistic. So in terms of the test statistic, if you notice, it is actually the same formula as you have seen for goodness of fit. So you still have observed minus expected square, so divide by the expected value. So step number 3 is going to be finding the critical value. And of course, for this case, critical value is going to be different, slightly different from the goodness of it. So the difference will be the back part over here. So we have r minus 1, c minus 1. So what does the r minus 1 and c minus 1 stands for? R stands for the row. So r is going to be the number of rows. And c going to stand for the number of columns. Okay, so depending on how many rows and how many columns that you have the data, you're going to put and you're going to multiply r minus 1 multiplied by c minus 1. So that will be the second parameter in your chi-square when you find the critical value. And again, so this one is also going to be a right-tail test. So meaning by if your test statistic is greater than critical value, you are going to reject the null hypothesis. And then last step, you're going to draw a conclusion. That's it. Okay, so meaning that goodness of fit, whether it's going to be goodness of fit, whether it's going to be contingency table, so the calculation is going to be pretty much the same. If you get the idea for one, you should be able to get the idea for the rest of them. Okay, this is going to be a final exam question from semester 1, 1920. So I'm going to start with this one. So it says, what should be done if the value of the expected frequency of goodness of fit test less than 5? So we had a GOF test and the expected frequency is less than 5. So what should we do? You have seen what I did before. So we are going to combine the category so with the adjacent with other adjacent categories. Okay, and this condition, it only applies for goodness of it doesn't apply for independent test. So there is no condition for independent test, so this only applies for goodness of it. Okay, and question number B, so it says over here, metal plates are evaluated according to their surface finish and placed into 4 categories. So this is going to be the first information that we have 4 categories. So the first category is premium, confirming, downgraded, and also unacceptable. So a quality engineer claims that the proportion of metal plates in the four categories are given by this percentage. So we are given percentage and we have to test whether or not our sample actually follow this percentage. So in a sample of 200 metal plates, so here we have a value of n. Our value of n is going to equal to 100. So 19 were classified as premium, 133 as confirming, 35 as downgraded, and 13 as being unacceptable. So the question asks you to use 0.5% significant level and test whether the engineer claim is true. So what does he claim? He claimed whether or not the four categories actually follow this distribution. Okay, so that is going to be our hypothesis. So H now, if you remember, so this is going to be a goodness of fit test. H now, we always agree with the statement given. So we're going to say yes. So the proportion of metal plates in the four categories are in the are 10%, 70%, 15%, and also 5%. So that is going to be our now. So basically all we have to do is agree with the statement. And of course the alternative will be the opposite. So I'm just too lazy to write it down, so I'm just going to copy it and change it slightly. And the null hypothesis, H1, so the proportion of the metal plate are not. So that will be the difference. So the top will be R, so we agree with that. And the alternative will be R not, so we do not agree with the percentage given. Okay, so now that we're done with the hypothesis, so we are going to calculate the test statistic. But before we start calculating, so what I'm going to do first is I'm going to start collecting the information that we have. So we have four categories. So this is going to be my observed, this is going to be my expected. So this is going to be our categories. This is going to be the observed value. So this is going to be the expected value. And this is going to be our calculation for the test statistic, so chi-square test. So categories, so we have four just now. So the first category is going to be premium, confirming, downgraded, and acceptable. So premium, confirming, what else? Downgraded and acceptable. Okay, so those are going to be our categories. And now I'm going to put the value for the observed. So observed is going to be whatever the value that is given in the question. So in the question, so we have a sample of 200 metal plates. So 19 are premium. So here I'm going to have 19 as the premium and 133 as confirming. This is going to be 133 and 35 as downgraded and 13 as unacceptable. So this is going to be 35 and this is going to be 13. So that is going to be our observed value. So now I'm going to find what is going to be the expected value. Okay, so how do we find the expected value? Expected value is the value that we expect if it actually follow this particular distribution. So if it follow this particular distribution, it says that premium should have been 10%. So how do I calculate the premium? So that is going to be 10% of a sample of, how many of that? 200. So that is going to be 10 over 100 multiplied by 200, and I will get a value of 20. So basically, if it actually follows that percentage, so our expected value is going to be a value of 20. And I'm going to do the same for the rest as well. So here, for confirming, so the percentage should have been 70. So I'm going to have 70 divided by 100, so multiplied by 20. So that is going to be 20 multiplied by 7. So I'm going to have 140. So that is going to be my value for the second category, which is confirming if it actually follows the percentage. And then for downgraded, so the percentage is going to be 15%. So I'm going to have 15 divided by 100 multiplied by 200. So that is going to be a value of 30. Okay, so that is going to be my expected value. And the last one is going to be a percentage of 5. So I'm going to have 5 over 100 multiplied by 200. So that is going to be a half of this. So I'm going to get a value of 10. And please, every single time you have calculated your expected value, so check whether or not they actually is equal n equal to 100. So this is going to equal n equal to 100. So this side, it should also equal to 100. So that is how you confirm so whether your value is correct or not. So here I have 160, 190, and 200. So that's correct. So my summation of expected value is actually a value of 200. Okay, so now that we already have the value of observed and expected, so what I'm going to do next is I'm going to start using the formula. So chi-square test is given by observed minus expected square, so divide by expected. So for each of this category, so this is what I'm going to do. So on this side, observed is going to be 19, minus expected is going to be 20, going to be square, so divide by 20, so I'm going to get the value. And the same goes for confirming, so I'm going to have observed, so which is going to be 133 minus expected, which is 140 square, so divide by 140, so that is going to be the value of the chi-square for this one. And I'm going to do the same for the rest as well. So 35 minus 30 square, so divide by 30, and this one is going to be 13 minus 10 square, so divide by 10, and what is going to be the value. And when we wanted to find the sum of our test statistic, so our test statistic is going to be the sum of this. So sum means you add them up together. So all this value that you get, so you add them up together, so that is going to be your test statistic value. So this is going to be my chi-square test. So I've calculated that beforehand. So I got a value of 2.1333. Okay, so you can verify that on your own. So when you calculated this, so you will get a value that the chi-square test statistic is going to equal 2.1333. Okay, so now that we already have the value of our test statistics, so the next thing that we're going to do is, so we are going to find, so what is going to be our critical value. So our critical value is going to be given by alpha k minus 1. Okay, but there's something I forgot to mention to you just now. So, and I've completely forgotten about checking this as well. So like after you have written your expected value, so check right away. So whether or not they are actually greater than 5. So for this case over here, I have no problem. I don't have to, what you call it, put together combined category, because here, so all my expected value is greater than 5. So I have no problem. So I started with 4 categories, and I also end up with 4 categories at the end. So after I have calculated my expected value. Alright, so now I'm going to substitute. So for this case, what is going to be our alpha value? So alpha value is going to be 0.5%. So that is 0.5 divided by 100. And I will get a value of 0.005. And my k value, for this case, I have 4 categories. So it's going to be 4 minus 1. I will get a value of 3. And all you have to do is simply by using the chi-square table. And you will get a value of 12.8382. So that is going to be your critical value. And now we're going to decide, so we're going to reject or do not reject. So that is going to be from a right tail test. So our critical value is going to be 12.8382. So therefore what happened is that our chi-square test statistic is going to fall somewhere in here, so which is going to be less than the the critical value. So therefore, so it goes into the acceptance region, so we do not reject H null. Again, so please do not use the term accept alternative hypothesis. So there's no such thing. You always use reject or do not reject H null. Okay, what does it mean by if we do not reject H null? So if we do not reject H null, so meaning that H null is actually true, that the proportion of metal plate actually follow this percentage. And this is actually what is being claimed by the engineer. So the question asks you whether the engineer's claim is true. Yes, so far we have an evidence that his claim is actually true. So we're going to say at alpha equals 0.005, or you can use 0.5%. So we have sufficient evidence so that the claim is true. Okay, so that is going to be the conclusion. Okay, so basically all you have to do is You have to be very careful, one, at calculating the expected value. Second, you have to check for each of the category, so whether or not they satisfy the condition. And then you have to be very careful in terms of when putting these values into your calculator. If you're using the silver or watt calculator, you can do it right away. You can put everything in here. I'm using the watt one, and I simply do the calculation like what do you call that? I don't do it individually. I simply put all the fractions together. Okay. However, if you're using the gray or the calculator, a gray calculator, the black one, so simply find each of them individually, then add them up together. So it would have been easier for you because there's going to be a lot of bracket involved if you still want to do the whole calculation together. So either way, it doesn't matter. It's going to be correct. So your decimal places will differ slightly, a little bit, probably the 2 decimal places. But the thing is that when I mark your final exam on this, I'm going to do back the calculation again. So whatever the value that you've written, I'm going to use my calculator and calculate that again. So whether or not, so I actually got the same value as yours. Okay, so that is going to be on goodness of fit test. So this is going to be the case when we are being given percentage. And this one over here, so it's going to be the case when we are being given, so let's read. So let's have a look at what information is being given over here. So it's going to be pretty much the same idea, but now instead of being given percentage, you are given a ratio. I'm not going to show you the whole calculation, but I'm just going to sort of like give you the idea, so how you tackle this problem. So here, the Ministry of Health claims that 1.3 million people in Malaysia suffer from adverse drug effect each year. So ADE is also known as unintended injuries caused by prescribed medication. So a study was conducted to identify the cause of 247 ADE's case. So if you were to sum this up, you will get a value of 247. But sometimes, so in the question, it doesn't actually tell you what is going to be the value of n. But all you have to do is sum up the frequency. So that is going to give you the value of n. Okay, so a medical officer found that dosing errors, wrong dosage prescribed or dispensed were the most common cause of ADEs. So table 4 summarizes the type of wrong dosage caused by 95 ADEs that resulted from a dosing error. So basically, this is not it. So actually, for this case, our n is going to equal 95. Is that right? Can somebody total this out for me and verify that the n is equal 95?
Yes, correct, Miss 95.
Okay, so n is going to equal 95. Okay, so the question says that. So I will leave this one for you. So you know this already. So this is just identify level of measurement with the qualitative variable. So our qualitative variable is going to be wrong dosage cost. So this has category. So when it says level of measurement, so you have to tell whether this is going to be nominal or ordinal. So can somebody tell me, is this nominal or ordinal variable?
Nominal.
Exactly. This is going to be nominal. Remember, ordinal mean you can order the variable, but for this case, we don't order these things, so therefore it's going to be a nominal variable. Okay, so when you get this kind of question, as I mentioned to you just now, I'm not going to do the whole calculation. I'm just going to give you the idea how to find the expected value. So your question, it is given in terms of a ratio. So first of all, so when you get a ratio, sum up the ratio, because it doesn't necessarily that the ratio is going to measure up to 100. Percentage, yes, the total is going to be 100, but ratio, it's not necessary that when you add them up together, it's going to be 100. So you have to total this up together. So what do you get when you total this up together? So this is going to equal 55, 60, 75, 25, 100, isn't it? Okay. So here the ratio, the sum, the total is going to equal 100. So how do you find the probability? Because expected value, so I'm going to write the expected value over here. So expected value is going to equal the number of samples, so multiplied by the probability. So how do you find the probability? You are going to use the ratio over here and come up with a percentage. So because ratio over the sum of the ratio multiplied by 100, so that is actually a percentage. Okay. So first, I'm going to start with the number of ADE. So here, the number of ADE, so I'm going to call this as category 1, 2, 3, 4, and 5. I already have that. This is A, B, C, D, and E. Okay, let's start with category A. So for category A, so it says that so basically the population is going to be divided by a ratio of 35, 25, 15, and 20. So for A, it's going to be 35. So that is a ratio of 35 over 100. So multiplied by the whole sample. So our whole sample is going to be given by 95. So 0.35 multiplied by 95, what is the value of that?
33.25.
Okay, 33.25. So therefore we have that the first category, the expected value is going to equal 33.25 because the probability, this is going to be the probability. So the probability that it falls into the first category is 35, so divide by the whole ratio. And it's going to be the same for B as well. So B is going to be 20. So I'm going to have 20 over 100 multiplied by 95. So what is the value for that?
19.
It's going to be 19. And what about C? So C is going to be 5 over 100 multiplied by 95.
4.75.
Okay, 4.75. And D, so that's 15 over 100 multiplied by 95.
14.25.
14.25. And the last one is going to be?
23.75.
That's going to be, okay, 23.75. Okay, so now that we already have the expected value, so now you have to check for each of the category, so whether the expected value actually fulfill the condition. So does this fulfill the condition? Yes or no? Okay, does these values that we get over here, our expected frequency, does it fulfill our condition for goodness of it? No one knows?
Yes.
Amir say, I don't know. Wow, Amir, that's a very, what do you call that? That's a very bold confession. I couldn't be mad over that. Okay, the thing is that this expected value, one of them does not fulfill the condition. So remember I told you before, so that when we have goodness of fit test, the condition is that the expected value must be greater than 5. So this one, no problem, is 33, this one 19, but this one is going to be our problem because it is given by 4.75 and the value of 4.75 is actually less than 5. So when it is less than 5, so we cannot leave the category by itself. So what we have to do is we have to combine both of this. So these two are going to be together. So now instead of having 5 different categories, so we are only going to have 4 categories. So I've done the calculation for this one. So this is actually give you a quick idea. So how it's going to be then. So how it's going to be then is, so we have to combine this. So previously, so this is going to be individually 13 and 9. But now for this case, I'm going to have a new category. So my new category over here is going to be C plus D. So my new category is going to be A, B, C is going to be added up together with D, and last one is going to be E. So my new K, so K is going to equal 4. So when I find the value of my critical value, so I have to be mindful about that. So now K minus 1 is going to equal 3 because my new category is going to equal 4 after we have combined both of these together. And the expected value is no longer going to be individual. So combine these two together, the observed value is going to equal 22. And the expected value is also going to be the combination of both of this. So that is going to be a value of 19. So basically that is going to be your new category. So be careful with the expected value. So this is going to be one of the way that the question can actually trick you. Okay, so whatever that doesn't fulfill the condition, combine the category. So now they are going to be together. And when you do the calculation, so now this is going to be my calculation. So they are going to be 22 because I have combined both of them, 13 and 9. So minus 19 because I also combine both of the expected values just to make sure that it is going to be bigger than 5. Okay, so that will be the idea. So how we actually handle when we come across a case that does not satisfy the condition. Okay, next, this is going to be goodness of fit, but this will be the second problem, so for which it involves probability. So we are going to test whether or not it follows a normal distribution. So again, so the formula, this is going to be the frequency given over here. So this is going to be our observed value. So whatever frequency that is given in the question, so that will be observed value. And how do we find the expected value? So that will be n being multiplied by p. So here we have been given that n is going to equal 175. So when you wanted to find what is going to be the expected value, so the p, the probability, so it's already given here. So this is your p. So when you wanted to find what is going to be the expected value, for example, for the fat content, which is between 26 and 28, so my expected value is going to equal n, so which is 175, multiplied by the probability of this category. So that would have been 0.043. So that will be the probability. So you're going to do this for each of the category. So by using the probability given. So previously in our previous syllabus, what happened is that you have to calculate the probability on your own. So we give you a certain value, you have to calculate your own probability, but that is no longer the case. So starting from last semester, so the probability is given, so you only have to use it. So simply apply this formula and find what is going to be the expected value by using the probability. So again, if you have listened to the video, so that have been prepared by Dr. Shahida, if I'm not mistaken, for this particular topic, so you would have seen how the calculation is being done. Again, I don't want to show everything together, so I'm just going to give you the idea of how it goes. Okay, next, I'm going to show you the calculation in terms of what we call that, the contingency table. So for contingency table, so as I mentioned to you, it has two different topics. So you could use it for independence test. You can also use that for test of proportion, which is called as homogeneity test. So this is an example of independence test. So how do you know it's going to be independence test? Because, so here, so the question asks you, so do gender and movie genre preferences related to each other? So we have two variables, so which is gender and also movie genre, and we have to test so whether or not they are related to each other. So there could be different term being used. The question could ask you, do gender and movie genre is related to each other? So are they independent to each other? So is there a relationship between gender and movie preferences? So those are going to be the type of words that they can use. So in order to ask you to test for test of independence. Okay, so basically this is going to be our data. So we have, for gender, we have men and women, of course. And for genre, we have animation, action, and also romance. So now let's see how we are going to do contingency table. So the idea is going to be the same as goodness of it. So it's only a slight twist between that on how do we find the expected value. So first of all, I'm going to start the null hypothesis. So remember the null hypothesis, we're going to always say that there is no relationship between X and also Y. So I'm going to say, so there is, no, not there is. So I'm going to answer the question. It says gender and movie genre preferences are not related. So there is no relationship between them. So this is always going to be the null hypothesis. And alternative, I'm simply going to do the opposite. I'm going to say that both of these are actually related. Okay, so remember null is not related. So alternative is going to be related. Okay, so now that I already have my hypothesis, so second step will be finding the test statistic. So for contingency table, so when you come across the data, the first thing that you have to do is you have to sum up each row and each column. Okay, this is going to be my first row. So this is going to be my second row. I'm going to sum each of them. For the first row, so I'm going to add 50 plus 120 plus 30 So that is going to give us a value of 150. So that is going to be for the first row. I'm going to do the same for the second row as well. So for the second row, I have 50 plus 20, that's 70 plus 80. So that is going to be 150. And you are going to do the same thing for the columns as well. So for the first column, so I have 50 plus 50, so that is going to equal 100, 70 plus 20, so that is going to equal 90, and 30 plus 80, that is going to equal 110. And after you have sum each column and row, so what you're going to do next is you're going to find the grand total. So the grand total is, you add this up together, so it's going to be 300, and even when you add up all the rows together, all the columns together, it is also going to add up to 300. So that is called as being the grand total. Okay, so now that I already have the grand total, so it's going to be the same as before. So let me add, I'm going to make a table. So let's do that properly. Okay, so this is going to be the position of my data. So I'm going to have 6 of them. So let's make it big. And this is going to be the observed value. And this is going to be the expected value and the other calculation. Okay, that's about right for now. And I'm going to need 6 of them. 1, 2, 3, 4, 5, and 6 is going to be somewhere down here. Okay, so what I'm going to use this table for, so I'm going to do the calculation in the table. So here, this is where I put all my observed value. And this is where I'm going to put my expected value. And this is going to be our calculation for the test statistic. So like what I did before. Okay, when I going to name them, I'm going to name them according to their position. So remember, if we have a matrix, so if you have a matrix, the way we label a matrix is RC. So we call it as, the formula is called as red chili. So R stands for the row position. So C stands for the column position. Okay, so meaning by I'm going to, this is going to be my data. So if I say it's going to be O 1 1, so this stands for that it's going to be at the first row and it's going to be on the first column as well. So it's going to be right here. So this is going to be O 1 1. So I have in the first row I have 3 columns altogether. So therefore I'm going to have 0 O 1 1. I'm going to have O12 for the second column, and first row third column is going to be O13. And the same goes for the second row. I have, this is going to be second row first column, second row second column, and this is going to be second row third column. So the observed value, so it's simply going to be the value over here. So I'm going to have 50, 70, 30. So 50, 70, 30. And the rest is going to be 50, 20, and also 80. So 50, 20, and 80. So those are going to be my observed value. All right, so how do we calculate for the expected value? Okay, for the case of contingency table, so the idea is going to be slightly different. It's going to be not slightly, but completely different from goodness of it. So what you have to do is, you have to make use of the sum that we find just now. For example, if I want to find what is going to be the expected value for this particular row and column, so what I have to do is, so I'm going to take the sum of the row, multiply by the sum of the column, divide by the grand total. So for this case, so it's going to be 150 multiplied by 100 divide by 300. 150 multiplied by 50, so divide by 300. So what is the value for this?
$25.
Sorry?
25.
25. Okay, so the value is going to equal 25. Hold on. So I was looking at something else here. 25. Okay, so this is actually, oh, sorry, that's the wrong value. Sorry, it's not 50. This is going to equal 100. Is that still the same value? Because this is going to be
50
150
now.
multiplied by 100. So it's going to be what value?
50.
50. So that is going to be a value of 50. And then when I wanted to find what is going to be for the column right next to it, so it's going to be 150. So divide by the sum of the column, that is going to be 90. Again, divide by 300. So that is going to be 150. So divide multiplied by 90. So divide by 300. So what's the value for that?
45.
So it's going to equal value of 45. So what about at 013? So what is going to be the expected value at 013? So I'm going to have 150 multiplied by 110. So divide by 300.
55.
Okay, it's going to equal 55. So I'm going to fill in the rest for you. So it's going to equal 50, 45, and also 45. So I just want to give you the idea. So how do we actually calculate the value of the expected value? Okay, so now that we already have the value of the observed and expected, so the calculation is going to be the same as what we have done for goodness of it. We only have to find the chi-square test, and the formula is still going to be the same. So it's going to be observed minus expected square, so divide by the expected. For this case, it's going to be observed is going to be 50 minus expected is going to be 50 square over expected. So that is no need to calculate that. So this is obviously going to be a 0. And I'm going to do the same for the second column. So I'm going to have 70 minus 45 square. So divide by 45. And this one is going to be 30 minus 55 square, divide by 55. And this one again is going to be 50 minus 50 square, divide by 50. That is going to be another 0 again. And you do the rest of the column as well. Okay, from your calculation, so you should get that. So the summation of this, so the test statistic, so that is going to give you a value of 50.5051. So in my scheme later, so I will give you detailed calculation of this. But for now, so this is just going to be the idea. Okay, now that I already have the chi-square statistics, so next what we're going to do is we're going to find the critical value. For contingency table, so the critical value is given by chi-square alpha r minus 1 multiplied by c minus 1. So now for our case, so what is going to be alpha value that is being asked in the question? So it's going to be 0.5% or 0.05. So I'm going to put over here 0.05. No, it's going to be 0.005 because it's 5%. Okay, what is going to be our rule for this case? So remember, for row, we have two rows. R is equal to, because we have gender, male, and also female. And column, we have three of them, so which is animation, action, and romance. So C is going to equal 3. So when I put it over here, so C is going to equal 3. So we apply into this formula. So I'm going to have 2 minus 1 multiplied by 3 minus 1. So that is 1 multiplied by 2. So I'm going to have chi-square 0.0052. That will be the parameter. And you can find this in the table, in the statistical table, and it will give you a value of 10.5966. So that is going to be our critical value. And this is going to be exactly the same as the previous one as well. So this is also going to be a right tail test. So if this is a right tail test, what is going to be our decision? Are we going to reject or do not reject based on the value that we have?
Reject.
Exactly. So it's going to be reject because if I were to sketch the curve, so the critical value is going to be 10.5966. Automatically, we have a value of 50. So 50 is much, much bigger than that. So therefore, what we're going to do is we are going to reject H null. So what does it mean by if we were to reject H null? So if we were to reject H null, so meaning that this is not true, alternative is going to be the correct one. So meaning that the gender and movie genre preferences are related. So we're going to see that at alpha equals 0.005. So the gender and movie genre preferences, they are related. So that is going to be our conclusion. That's it. So that is all that you have to do. Okay. So as long as you do the calculation correctly, you know how to find the expected value. So you did this very carefully. and you get the correct value, so that should be no problem with your contingency table. Because contingency table, I think it's easier than goodness of fit because you have no condition that you have to check for. As long as you know how to do the calculation, that's it. So it's going to be pretty much the same in terms of the calculation. Okay, and the last one, I'm not going to do the calculation of this, I'm just going to give you the idea. Remember, for contingency table, we have two type of tests. So one is the independent test and the other one is test for homogeneity. So this is the test for homogeneity. So what happened is that the question asks you test at 0.5% significant level whether the number of accident is the same among the group of drivers. Okay, so when you come across question like this, it gives you categorical variables. So we have number of accident and drivers, both of them are in terms of category. So they ask you to check whether the category is actually the same. So this is going to be called as the test of homogeneity. In terms of the calculation, it's still going to be the same as previously, only the hypothesis will be different. So if you're not sure what is going to be the hypothesis, for example, here it says, so whether number of accident is the same among the group of drivers. So group is going to be our main focus. The group is going to be our proportion. So how many groups are there? So there are going to be 3 groups. So meaning that your proportion, there will be pi 1, pi 2, and also pi 3. However, if you're not sure, like how many pi are there, so it's going to be safe for you to actually do your hypothesis in terms of words. So all proportion are the same. At least one of the proportion is different. So that will be helpful. And you don't have to worry because for the final exam, so the question, it will be arranged according to the chapter. So when you come across the final exam, so the first chapter you're going to come across is going to be, I'm not sure if there's confidence interval question. I think there is none of those. I think there's only question on hypothesis testing. So I will confirm that later, whether chapter 2 is included or not. So usually in final exam, there are certain cases that we combine chapter 2 and chapter 3 together. But I think for this semester, there is no chapter 2, but everything is going to be in chapter 3. Okay, so when you come across your question, so it's going to be arranged according to the chapter 2, 3, 4, 5, and 6. So the last 2 question is definitely going to be on this particular topic, chapter 6. The last one is definitely going to be contingency table. So the previous one is definitely going to be goodness of fit. So you just have to know how to do the calculation. Okay, so I don't have any more thing to explain about this particular chapter. Do you have any question? So regarding our discussion today or anything that you'd like to know about?
I have a question.
Mm-hmm.
The previous question about the gender and movie genre.
Okay.
For the Hishna, it's not related,
Okay.
and the alternative are related.
Yep.
Okay. I just want to. I don't understand for
Mm-hmm.
the Hishna and H1 in question 6 final exam. The first question that you teach us earlier.
Which one? Are you referring to this one or goodness of it?
Sekejap. Nak tengok. Saya Melayu sebenarnya cepat sikit lah.
Boleh.
Okay, sorry. Nak kata yang untuk soalan 6 yang final exam tu, kan Miss ada cakap ada yang dia punya yang not tu, macam dia kan ada yang ini kan,
Goodness of it.
Guna Rafiq ni, kan
This question,
kata
isn't it?
yang claim tu macam positif lah kan. So bila alternatif ni kata macam negatif, not.
Betul?
So kalau macam nak dibandingkan yang soalan yang yang gender and movie tadi tu, dia kata terbalik kan.
Tapi alright. So the thing is that, okay, I will translate it. So your friend Amin here asked me, why is it that for this case, we agree with hypothesis and alternative we do not agree, but for the case of the movie, at the top is going to be not related, at the bottom is going to be related. So the thing is that they are 2 different things. So let me write it over here. No, I don't want that. I want a blank page. Okay, so they are actually 2 different things. So we discuss GOF and also contingency table. So contingency table. So they are different things. So we cannot assume that the idea of both of them are going to be the same as well. They're different. So for goodness of it, alternative is going to be agree with claim. So it's always going to be agree with claim. So null is going to be agree with claim. Alternative will be disagree with claim. But for contingency table, so the null hypothesis is no relationship between x and y. Between x, y, a relationship exists. So between x and y. So this is always the case. Okay, for goodness of it and contingency table, so of course the hypothesis will be different. Goodness of it, you agree with claim for now. Contingency table, it is always no relationship between x and y. I mean, does this answer your question?
Yes, thank you. Selalu confuse macam ni. Thank you, Miss.
Jangan confuse. They are two
Ada
different
ya.
things. Goodness of it dengan contingency table. Anything
Thank
else?
Miss,
Problem?
for the exam, is there any specific topic where we have to focus more on?
For the final exam, to be honest, I only saw the question once and I don't really remember. So the only thing that I remember is, you remember how tricky the test is? It's going to be the same for the final exam as well, because we decided to do open book format. Of course, you have to study for chapter 3. Hypothesis testing is definitely going to be there. Chapter 4, you have to study both ANOVA and 2A ANOVA. Even chapter 5, both simple linear regression and multiple. And chapter 6 is going to be the two topics that we discussed today. So pretty much everything that we discussed is going to be in there in your final exam. But for chapter 2, whether or not there will be confidence interval, I will confirm that later. I will ask the coordinator if she still remember about the question. But other chapters, it's going to be pretty much everything. My suggestion is that what is the best way to study for the final exam is to do the final exam question. I think that if you go to Kalam, so there are compilation of final exam question from, I don't know how many semesters the coordinator have put over there. So the best way to study is take one. So set the timing. It has to be answered in 3 hours, and then start answering the question, and then only you'll be able to realize. So you have problem with chapter 4, or you have problem with chapter 5, or you have problem with chapter 6, and so on. Then only go back to the topic and have a look at whatever that is still not clear to you. All right, so anything else?
Miss, when will be having our final quiz 5?
As I mentioned to you before, our final quiz 5 is going to be on simple linear regression. It's going to be on this coming Monday. I will open Kalam for 2 hours, probably like from 8:30 until 10:30 p.m. So it will be during the evening, if you don't mind. But if you have, for example, if it clashed with other courses, or you have something else to do with other courses at that time, do let me know, so we can be flexible about it, because I don't mind whether you want to do it on Monday or Tuesday. It doesn't really matter, as long as you give me space for me to mark the quiz, so that by the end of the week I can actually release all your coursework marks, including the assignment.
All right, Miss. Thank you.
Okay. So any other questions? So for the final exam, so please read the question multiple times. Like, it's going to be tricky, definitely, but as long as you read it again and again, you should be able to understand it well. And in terms of what you call that, it's not going to be much different of what we have discussed in class. If you really understand what we discussed, the conceptual stuff, you would have no problem answering the question. Miss, do you have the answer scheme for the past final exam? Yeah, Shafiq asked me here on the chat if I have the answer scheme for the past 5-year final exam. I do. Probably you might want to check in Kalam first. So go to Kalam, check so whether the mark scheme is there or not. But if it's not there, then yeah, I could provide you with the mark scheme if you want. I will just post it on the group. Just mention to me like which semester do you want, and I'll give it to you. Anything else?
Okay, Miss.
No problem. Okay, so if there's no more problem, so I am going to stop here for now. So since this is going to be our last lecture, yeah, I think we're not going to have anything else. I'm not going to do revision because I think that I have done much revision to you. I've given you like all the summary for all the chapters that you needed, and hopefully, I really hope that it's come to use. It's helpful for you in any way. So I would like to apologize if there's anything insufficient while I'm teaching you this course in my section. And so good luck and all the best for the final exam then. Okay, so let's stop here now. Bye.
Thank
Thank
you,
you,
Miss.
Miss.
Thank you, Miss.
Problem. Right.